It's 1965, and Boeing's engineers are staring at what seems like an impossible challenge. They need to design an aircraft that's 2.5 times larger than anything that's ever flown commercially. An aircraft so massive it would require building the world's largest factory just to assemble it. An aircraft that would force Boeing to take on the largest corporate debt in history, literally betting the entire company on a single design. The result? An aircraft that didn't just change aviation, it revolutionized the entire world. The Boeing 747 shattered every assumption about what was possible in the skies, democratized international travel for millions, and physically reshaped the infrastructure of every major airport on Earth. But what you don't see when you look at that iconic silhouette are the remarkable secrets hidden within its aluminum skin. Engineering decisions born from military requirements that nobody talks about. Design choices driven by a phantom threat that never materialized. Revolutionary innovations that seemed impossible until they weren't. Today, I'm revealing the most extraordinary secrets of how the Boeing 747's design changed aviation forever. Trust me, the most surprising one isn't what you think. Would it surprise you to learn that the 747 was never intended to be a long-term passenger aircraft? Here's a secret that even aviation enthusiasts rarely know. The 747's entire design philosophy was shaped by a threat that never materialized: supersonic passenger jets. In the 1960s, everyone believed the future of long-haul travel was supersonic. The Anglo-French Concorde was under development. Boeing was working on their own 2707 supersonic transport. Juan Trippe, the visionary president of Pan Am, was convinced that subsonic jets would soon be obsolete for passenger service. He thought the 747 would have maybe a decade of relevance before passengers abandoned it for aircraft that could cross the Atlantic in under 3 hours. This supersonic shadow led to one of the most brilliant strategic decisions in aviation history. The 747 had to be designed from day one as a dual-use platform, an aircraft that could be easily and efficiently converted from passenger service to cargo operations. When supersonic jets took over passenger routes, the reasoning went, the 747 would seamlessly transition to hauling freight. The sheer scale of the 747 would have been a physical impossibility without a concurrent breakthrough that most people never think about: the high-bypass turbofan engine. The turbojet engines that powered the Boeing 707 were simply inadequate. They were too loud, too inefficient, and lacked the massive thrust required to lift 735,000 pounds of aircraft into the sky. The enabling technology came from an unlikely source: General Electric's work on the military C-5 Galaxy transport. The high-bypass design uses a colossal front fan to pull in enormous volumes of air, directing most of it around the engine's hot core rather than through it. This cooler, slower-moving bypassed air mixes with the hot exhaust, generating immense thrust far more quietly and efficiently than pure turbojets. But here's where it gets fascinating and terrifying. While GE was committed to the military project, Pratt & Whitney took on the almost impossible challenge of developing a commercial version, the JT9D, specifically for the 747. The development nearly destroyed the entire program. Early JT9D engines were plagued with catastrophic problems. Compressor stalls, something called ovalization, where takeoff stresses literally deformed the engine casing, causing turbine blades to fail spectacularly. The issues were so severe that dozens of fully assembled 747s sat outside the Everett factory with concrete blocks hanging from their engine pylons as ballast, because they couldn't be fitted with working engines. After an intensive joint effort to reinforce the engine casings, they solved the problems. The resulting engine was extraordinary: over 43,500 pounds of thrust, nearly double that of its predecessors, while consuming a third less fuel per passenger mile. Here's something that will change how you see every 747 freighter. That distinctive nose isn't just aerodynamic styling. It's a 20-foot-tall cargo door that swings upward like a massive jaw. This capability, directly inherited from the military CX HLS project, became the cornerstone of the 747's dominance in global logistics. The nose-loading advantage created entirely new possibilities for international trade. For the first time, airlines could transport massive items that simply wouldn't fit through the side doors of other aircraft. Oil drilling equipment, power plant turbines, entire aircraft fuselages, even space station components. Items that previously could only move by sea could now fly, reducing transit times from weeks to hours. This unique capability gave 747 operators a stranglehold on the most profitable segment of air cargo, oversized freight. By 2004, approximately 300 Boeing 747 freighters were carrying roughly half of the world's entire air cargo volume. That's the legacy of a military requirement for front-loading tanks and helicopters. The irony is remarkable. While passenger airlines eventually abandoned the 747 for more efficient twin-engine jets, the freighter version remained irreplaceable. The very last Boeing 747 to roll off the production line in 2023, after 54 years and 1,574 aircraft, was a 747-8 freighter delivered to Atlas Air. The military DNA that created the design outlived every other aspect of the program. The 747 didn't just change aviation, it physically reshaped the ground infrastructure of the entire world. Every major international airport you've ever walked through was fundamentally redesigned because of this single aircraft. Think about the scale of the challenge. The original 747-100 had a wingspan of 195 feet 8 inches, a length of 231 feet 10 inches, and weighed up to 735,000 pounds fully loaded. These dimensions far exceeded the design limits of airports built for the Boeing 707 era. When a single 747 landed, carrying 350 or more passengers, it created a massive pulse of people and baggage that completely overwhelmed existing facilities. The necessary modifications were staggering in scope. Runways had to be lengthened and strengthened. Taxiways required widening and reinforcement to prevent pavement damage from the aircraft's immense weight. Passenger terminals needed dramatic expansion. Check-in halls, security checkpoints, customs facilities, and baggage systems all had to be scaled up to handle the concentrated passenger flow. Even the jet bridges had to be modified. Existing passenger boarding bridges were too short to reach the 747's doors, necessitating expensive extensions at gates worldwide. Boarding lounges designed for 150 passengers had to be significantly enlarged to prevent chaos before departure. London's Heathrow expanded Terminal 3 specifically for the 747 in 1970. New York's JFK underwent massive modifications in the late 1960s. This pattern repeated at every major international airport globally. The most extraordinary secret of the Boeing 747 isn't about its past, it's about its permanent, indelible impact on our world. While the last passenger 747s have been retired from major airline service, the Queen of the Skies achieved something far more profound in longevity. It engineered the modern world. The 747 didn't just transport people, it transported possibilities. Over its passenger service lifetime, 747s carried an estimated 5.9 billion people. Think about that number. Nearly every person on Earth today has been touched by the 747's democratization of international travel, either directly or through someone they know. The aircraft's designed-in versatility means its influence continues. 747 freighters remain the backbone of global logistics, moving the products that fill our stores, the components that build our devices, and the medical supplies that save our lives. The engineers who created this marvel didn't just solve technical problems, they opened doorways to human connection on a scale never before imagined. They gave wings to dreams and made the world smaller by making the sky bigger. What story of engineering triumph inspires you most about the 747? Have you ever flown on the Queen of the Skies? Drop a comment below and share your memories of this incredible aircraft. And if this deep dive into aviation history fascinates you, hit that subscribe button because there are countless more engineering marvels waiting to be explored. The Boeing 747 taught us that when you combine visionary thinking with practical engineering and economic wisdom, you don't just build an aircraft, you build the future. And that lesson will echo through the skies forever.